everyone, when an equation x squared plus 4 sine of theta x plus cosine of theta equals 0, and our angle theta has to be between 0 degrees and 360 degrees, has different number solutions, two different ones, we're going to find the range of theta. So basically what we're going to do is look at the discriminant for this. So if you have the discriminant is b squared minus 4ac. So basically your b is going to be 4 sine of theta. It's in front of the x, that's your constant, square it, minus 4, your a is 1, and your c is 6 cosine of theta. And I forgot to put the 6. So 4 times 6 cosine of theta. Now, we want this to be positive because we have two different solutions. And we want real solutions. We do not want imaginary solutions. All right, so simplifying this, we're going to get 16 sine squared of theta minus 24 cosine of theta, and it has to be greater than 0. So let's factor out a 4, and then you'll get 4 sine squared of theta minus 6 cosine of theta has to be positive. And you can divide both sides of the equation by 4. So now we have 4 sine squared of theta minus 6 cosine of theta is greater than 0. All right, let's rewrite sine squared because we have this quadratic going on here. So we want to write this in terms of cosine. So I'm going to use the fact that sine squared of theta equals 1 minus cosine squared of theta using my Pythagorean identity. All right, so this is going to equal 4 times 1 minus cosine squared of theta minus 6 cosine of theta is greater than 0. All right, simplifying all this, we'll get 4 minus 4 cosine squared of theta minus 6 cosine of theta is greater than 0. Rearranging and negating everything, I want to negate everything because I want my lead coefficient to be positive. We're going to get 4 cosine squared of theta plus 6 cosine of theta minus 4 has to be less than 0. When I negated everything, I have to flip this sign. You have to be careful with that. All right, so basically I can factor out a 2. That'll give me 2 cosine squared of theta plus 3 cosine of theta minus 2 has to be less than 0. That gives me factoring. You can divide both sides by 2, so that goes away, and this is still going to be 0. So all we have to do is factor that. That's going to be 2 cosine of theta minus 1 times cosine of theta plus 2. Now this is, I'm running out of room, but this has to be less than 0. Now if you look at this, this piece, you have cosine of theta plus 2 has to be less than 0. But this is always positive. So basically it's saying that cosine of theta is less than negative 2, but cosine of theta plus 2 has to be positive. So this has to disregard that one. So the only one we're going to use is this one right here. So let's do that. We have 2 cosine of theta minus 1 is less than 0. Therefore, cosine of theta is less than, you add the 1 divided by 2. 1/2. All right. So we want all values less than 1/2. So we have 1/2 here. All right. And then this is negative. That's less than 1/2. This is less than 1/2. So you keep going around. -1 is less than 1/2. Keep going around. You could use a graph on this too. And then we get back to 1/2, which is not less than 1/2. So basically we're going to 1/2 to 1/2. But we're going to write it as pi divided by 3 is less than theta. It can't equal it, right? It's just less than to 5 pi divided by 3. Again, you could use the a graph if you wanted to, or you can use the unit circle. So this would be like open intervals here. If you're doing degrees instead, which is probably what we should do since that's how they gave us the domain, that would be our angle is going to be between 60 degrees and 300 degrees. So it's probably better either one of these. Thank you. Have a nice day. Bye-bye.